So we are now on lesson 5, and lesson 5 is the last unit we will do in topic 6, and we're talking about transformations of exponential functions. Open your book to page 132. 6.5 is already out in Schoology. Your teacher will let you know when that is due. Do have your Chromebooks because we are going to go to Desmos.com during class. So have that out ready. And if you're watching this video, you obviously already have it out and ready. So we're going to talk about transformations. We've actually done transformations of lines. Now they're a little more interesting and it's a little more obvious, I think, on some of them. So keep that in mind. You've already kind of done this. So here we go. We're going to actually start on page 132, not 131. So how does the graph g of x equals 2 to the x plus 1 compare to the graph of f of x equals 2 to the x? So here is what's called our parent function. Okay, so that is our parent function. The red one in red is called the parent function. What that means is everything is based off of that one for all these other ones. So this is considered a kid or a child off of that parent function, if we want to put it in those kind of terms. So look at this. Some of you probably already have an idea of what's going to happen, don't you? Okay, and if we were in the room, we'd talk about that right now and why and where we saw that. So we don't really have any predictions right now. I'm not going to do a prediction because if we're not in the room. So we're just going to go and plug this in. So we've done this before. We're going to take 2 to the negative 2, 2 to the negative 1. Okay, we've done this before. And we're going to do it all right here. And then we're going to graph. So this is our x value. And this is 1 over 2 to the second. So this is 1/4. Okay, and then this is 1 over 2, 1, 2, and 4. Okay. Now what this is saying, I wrote that wrong. This should say 2 to the x plus 1. Okay? And think about it. So I just found 2 to the x. Now I'm just going to add 1. So if I add 1 to 1/4, I get 1 and 1/4. I get 1 and 1/2. I get 2. I get 2 plus 1, which is 3, and 4 plus 1, which is 5. Okay? So what we're going to do is we're going to graph 2 to the x in red. Let's make our axes. I'm just going to draw that in. Now, I know you do not have this in your book, so it's kind of frustrating. Hopefully you still have that piece of graph paper earlier this week so that we can just use that. We can put this on that graph paper, okay? And you can put this table that I made on that graph paper too. So now we're going to plot this in red. So we have negative 2 and we have 1/4. Why is that not going in red? Okay, so here we go. And then we have 1/2. So we're going to be here. We have 0, 1. We have 1, 2. And we have 2 and 4. 1, 2, 3, 4. So this is y equals 2 to the x. We're just going to have that go up like this, okay? Now we're going to graph this other one, 2 to the x plus 1 in green. So here we go. Negative 2 is 1 and 1/4. Negative 1 is 1 and 1/2. 0 is 2. 1 is 3. And of course 2 is 5. Okay, now you'll notice with this one what happens to, so let's go back for just a second. If I'm looking at y equals 2 to the x, notice my asymptote is right here. That's going to be that x-axis. Okay, and that gives me y equals 0. That's my asymptote. Now if I look at this green one, when I go to graph this green one, what happens to my asymptote? That's right, it moves up 1. That's going to be important we pay attention to that. We'll talk about more of that in just a second. So this graph, whoops, went a little too high on that one. I'm going to start over here. This one goes up like this. Okay, and then it's going to come along and skirt along that. Let me draw that asymptote in a different color so you can see the asymptote for this one is right here. Okay? So that's where our asymptote is. So think about that. What did our asymptote do? Our asymptote on this one Well, it moved up 1. So it moved up 1, and why did it move up 1? Because of that plus 1. So our asymptote is now y equals 1 because it moved up 1. This made it move up 1. Okay, it moved up 1. Okay, compared to the original. Does my domain change? Can I have all the same stuff? Yep, all real numbers. Does my range change? Yes, it does, because my range is based off of my asymptote. So my range is based off my asymptote. My asymptote is 1, so my range is going to be y is greater than 1. Okay? So that asymptote determines your range. It's still an increasing function. But do you see what happened with this right here? Okay. So the next one we're going to look at, and this is still just in your book on page 132, it says, how does the graph j of x equals 2x to 2 to the x minus 1 compared to the graph of 2 to the x? Well, what do you think happens? That's right. It's going to shift down 1. Going to shift down 1, okay, because we're just this right out here. Now, you might remember when we had a rule back when we were doing these with lines, so hopefully you're connecting this with lines. These shifts are the exact same kind of thing. We're shifting it. So when we have f of x is equal to 2 to the x plus k, what happens, okay, and we're going to use 2 to the x, we could use 3 to the x, okay, but if I have f of x is equal to an exponential function plus k, it's going to shift up. However big k is. Shift up k number. So if this was plus 5, it would shift up 5. If f of x is equal to 2 to the x minus k, it's going to shift down. Now that's going to also affect the asymptote. So my asymptote is going to also shift up 5. Well, my asymptote is usually y equals 0. Sorry, shift up k. So if my asymptote is usually x equals 0, now my asymptote is going to be y equals k. Right? Same thing here. Your asymptote is going to be y equals whatever k is. So, and it's going to go down below 0, so it's going to be a negative number. So it's going to be whatever k is, which would be a negative number. Okay? Does my y-intercept change? Yes. It also shifts. It shifts up k. Now your y-intercept for your parent function, f of x is equal to 2 to the x. Okay? Think about what that is. So let's just sketch it. This is what it looks like, right? What's my y-intercept? Well, my y-intercept for this one is going to be equal to 1. Because whenever I plug 0 in, which is your y-coordinate, I plug 0 in for x, I'm going to get that my y-intercept is 1. So my y-intercept is also going to shift up k. So if my y-intercept is usually 1, this is going to be 1 plus whatever k is. Okay, it's because it's going to shift up or down. Same thing here, so it's going to shift down k. So it's going to be y is equal to 1 minus k, and that's going to be your new y-intercept. So your asymptote changes and your y-intercept changes. So just pay attention that that k is going to affect everything. Okay? So right now I want you to go to page 108, and we're going to look at number 8 on page 108. Okay? And what I want you to do is look at this function. What is happening here? Okay? So hopefully you realize that you're going to shift down 4. Okay? This tells you shifts down 4. Sometimes what makes it easier is if you actually just sketch this parent function. And when I say sketch this, what I'm talking about is that we know that it's going to just kind of come along and go right up like this, right? Mark your y-intercept. Your y-intercept is the point 0, 1. That might help some. It's always going to look pretty much like this. Your asymptote here, of course, is y equals 0. There's your asymptote. But it just makes it a little easier to see what's happening. So now when we look at this, if it shifts down 4, Okay, here's my asymptote right here. It's going to go down 1, 2, 3, 4. So my new asymptote is going to be right down here. So my new asymptote is going to be y equals -4. Hence what k is -4. That also means that my y-intercept is going to shift down. And so my y-intercept y-intercept is going to go down 4 also. 1, 2, 3, 4. So this is going to be where your new y-intercept is. And if I were to graph this, it would look like this, because I'm just shifting it down 4. It doesn't go parallel, but you can see that they match up if I were actually doing it legitimately. So that means my y-intercept is now down 4 from 1. So it's 1, 2, 3, 4. So my y-intercept is 0, -3. Okay, hopefully that helps some. We're going to come back and practice some more in a bit. Now back to page 132, it says compare the graph of each function in the form of g of x is equal to 2 to the x minus h within the graph of 2 to the x. What effect does h have on the graph of each of these? Now you might remember what's going to happen, but what we're going to do right now is we're going to take this function right here, 2 to the x plus 2, and we're going to go out to Desmos.com and we're going to graph this and see what happens. So here we're now on Desmos.com and we're going to enter the equation. Now, in order to actually for it to make sense, we have to first put in the parent function. So y equals 2 to the x power. We have to have that function in order to compare to it. So we're going to start off by putting that one in. Then we're going to put in our new one, which is y equals 2 to the x plus, okay, it wants to go down. So we're going to have to put it in parentheses, I bet. I'm going to go back just a little bit, and we're going to put this one in parentheses. So we're going to go parentheses x plus 2. It will probably take it better. That way we know we're covered. Okay, so now look at what's happening. Did my asymptote change? No, it did not. But look right here. There's my intercept, right? Look what it did. It moved over. Look at my intercept. Look at my intercept. My intercept is 0, 1. Now what's my... Okay, look at what's happening there. It shifted over. Where did it shift over to? Okay, also look compared to, so there's my y-intercept, I'm sorry. Now look at what my y-intercept is. But what we really did from this one over to this one is we shifted it over how much? Didn't we shift it over 2 places? I can't get it to go exactly to... There it is, -2, 1. So it shifted this direction, and it shifted 2 over. And look at what happened. Do you remember? And that's kind of a good thing that we had to put in parentheses. That might jog your memory. When it's in parentheses, it's an opposite machine. It's going to go in the opposite direction. And notice that it's affecting the x now, not the y. So it's going to go over here to that -2, 1. So it shifted to the left. Okay, let's go back to our note. So let's look at this function now, and let's say make comments about what's happening here. So we know that it had a shift. It shifts left 2, that's an F, 2 places, right. Did my asymptote change? Did the asymptote change? No, it did not. So my asymptote is still what it was before. My asymptote does not change. And it makes sense that it wouldn't change because I didn't change the graph. The graph didn't change vertically. It only changed horizontally. So it shifts 2 to the left, okay? So it goes in the opposite direction. Remember those parentheses make it go in the opposite direction. So the parentheses are going to make it go in the opposite direction. Now let's talk y-intercept. So think y-intercept for a second. My y-intercept is always going to have an x-coordinate of 0. So if I would put 0 in here, 2 to the 0 plus 2, that would give me 2 to the second, which would give me 4. So my y-intercept, and a lot of times it's just easier to plug a 0 in to see what's going to happen. My y-intercept is going to change, and I can just find that by plugging 0 in for the x. So my y-intercept is 4. And again, I can always find the y-intercept by plugging 0 in for x. That doesn't change, even though it's an exponent. Okay, let's look at this next one and see if we can do it without graphing. Let's put in all the things we know, but if we need to graph it, we can always do that. So, what do I know about it? It shifts. How does it shift? It shifts right. 2. Because we always want to go opposite, because remember, this is like it's in parentheses. It's going to shift right 2. Does my asymptote change? No, it does not. Because, again, I'm going right. I'm not going up and down. Okay, now let's talk about the y-intercept. What happens to the y-intercept? Remember, I can plug a 0 in. So if I plug a 0 in, I'm going to get 2 to the 0 minus 2, which is 2 to the negative 2, which means that it's 1 over 2 squared, which is 1/4. Okay, so my y-intercept is going to shift, and it's going to become 1/4, and it's going to shift the whole thing. Now, if you want to, let's go out to Desmos for a second. Let's plug that in, and instead of up here, we're just going to change this to be a minus 2. Okay, and see how it shifts it. It still shifts it over, but it's going to shift it to the right. So my y-intercept right here, my y-intercept of 1, okay, it comes over here. And notice what my y-intercept becomes. It also shifts it down to that number right down there. Okay, that becomes my y-intercept, which is 0 and 1/4, which we already came up with. Okay, so it's going to shift it down. Good. So now we're going to look at describe how the function that results in a vertical translation is different from a function that results in a horizontal translation. Okay, so a vertical, we've kind of talked about that, but let's just see. Let's kind of put it all together. Vertical, horizontal. So if it's a vertical, that means I'm adding a constant to the function. Add a constant to the entire function. Okay, so I'm going to have y is equal to 2 to the x plus k right here. Whereas if vertical, it's going to add to the exponent. Add to exponent. So it's y is equal to 2 to the x plus k up here in the air. Here my asymptote is going to change. And it changes up and down by k. According to k. Here my asymptote does not change. And I know I've said this many times, but I think if we maybe write it out one more time. And then my y-intercept. My y-intercept is going to change on both of these because it's going to go up. So my y-intercept here, you're just going to add k to whatever 1 is to 1. It's always 1 plus k because it's going to, your y-intercept on your parent function is 1, no matter what your parent function is. Okay, every parent function, y equals 3 to the x, y equals 5 to the x, your y-intercept is always going to be 1. Whereas here, it's going to shift it, but it's not an easy way to say it. So my y-intercept, the easiest thing I can tell you is plug 0 in for the x. Plug 0 in for x. Plug 0 in for x. Wow. Plug 0 in for x. For now, we're just going to go with that. Algebra 2, you'll learn some more. Okay, this is not in your book. We're just going to talk through. Oh, I spelled thinking wrong. So, just forgot an I and an N. I'll correct that later. How can you compare the properties of G given the table to the properties of J given the graph? Both functions are translations of f. So what we're going to do is we're going to look at this function first. Well, you can see right here, okay, look at this point. So there's our y-intercept, and then when x is 1, y is 2. So this is still the parent 2 to the x. So that might help you. So look to see what the parent function is. They gave us a parent function. That's f of x. Look at that. So then you have something to base it off of. Well, when I look at j of x, what did it do? It shifted down 2. So that means my k for j of x is going to be 2. So I have 2 to the x, and it shifted, whoops, how much did it shift down? My gosh, I can't count. So it shifted down 1. So compare there. So do that same thing here. Okay, sometimes what's easiest is to look at 2 to the x. And I know when x is 0, this is going to be 1. When x is 1, this is going to be 2. Okay, so you can tell what's the shift here. Well, it went up 2, right? It went from a 1 to a 2. It went from a 2 to a 4. So if I were going to write out g of x, I would say that it shifted up and down by 2. So therefore, I have 2 to the x plus 2. Okay, hopefully that helped. We'll look at some more of those later too. So this is example 3 in your book, and it says the graph of the function b is a vertical translation of the graph. So here's my parent function, and it has a y-intercept of 0. So it's a vertical translation. All of a sudden, my y-intercept is 0. Didn't mean to cross that off. Then what it says is we have a c of x. So we have two different functions, a b of x and a c of x. And it says how does it compare to the graph of b? I'm going to tell you right now, if you're given this question on EOC, go to Desmos and graph it. We're going to sketch it right now just so we have a better understanding of it. So I'm going to sketch these three functions. Okay, you can do the same thing. And I'm going to mark a 1, 1, 2, 3, 1, 2, 3. I don't need those. Don't need those. Okay, so here I go. In red, I'm going to graph my parent function of 3 to the x. So I'm going to have 0, 1. That's always a function. Then if I plug in 1, I'm going to have a 3. There's my parent function. It has an asymptote that just comes along. There's my parent function. If you have another color, you might want to pull that out right now. Then it says that b of x, so b of x, what it's doing is it has a vertical translation and the y-intercept happens to be 0. So here's my y-intercept. So what happened? It shifted down 1. So then that means my asymptote also shifted down 1. So my graph looks like this. Now that means that whenever 1 was, that's going to shift also. So my graph now looks like that. Okay, then comes along another graph, and we have c of x is 3 to the x plus 1. So what happens here? It goes 1 up. So my y-intercept goes 1 up. My when x is 1 goes 1 up. So my graph now looks like that. My asymptote comes along, and it's right here. Okay, so how does the graph of 3 to the x plus 1, that's my purple one, compare to my green one? There is a difference of 2. There is a shift of 2. This one, c of x, is shifted up to above b of x. That was a tough question. I totally understand that's a tough question, but it's good for our mind to stretch, so it doesn't hurt us at all. But I think you're going to be fine on homework. This was harder than the homework that I picked, so you're in good shape. Okay, now look at this one here. It's going to ask you, this one's much easier. So look at this one. What does this shift up? It shifts up down 3. So this goes down 3 compared to the graph that goes up 4. So what's the difference between them? If this one goes down 3 and this goes up 4, think about that. This one has gone, so here it is. That's my original function. It's gone down 3. 1, 2, 3. Whereas my second function has gone up 4. So 1, 2, 3, 4. So what happened between it? There is a difference. So how does it compare this one to that one? P of x is 7 up from m of x. Okay, good. Moving on. So on this one right here, it brings everything together that we've already talked about. We're going to be writing this out in your book, so don't worry about it too much. But it just shows the different shifts. If it is k, if it's just adding to the function, it's going to go up and down from it, up and down. Okay? Where if it is shifting h up in the exponent, it's going to go horizontally. So it's going to shift horizontally. So the essential questions. How do changes in parameters relate to the translations of the graph of the exponential functions? What they mean by parameters, this is k and this is h. So when a constant is added to the function, f of x is equal to whatever plus k or minus k, then it's going to shift it up and down. This is up and down. Okay, the asymptote is going to change. And how does it change? It changes by k, whatever k is. If it's positive k, it moves up. Negative k, goes down. Your y-intercept is going to change by k also. Now, if the constant is subtracted from the exponent, that's h. This is going to be a horizontal shift. Okay, so this is going to be right and left. And this is going to be where the asymptote doesn't change. I didn't change it vertically, so the asymptote doesn't change. And the y-intercept, it does change, but for now we're just going to plug 0 in for x. It's just easier. Okay, how is the effect of k on the graph of this similar to this? It's because it shifts it. But when we subtract it, it's totally different than we add it. So I'm going to just say C number 1. We already answered that. So for number 3, error analysis. Tariq graphs g of x is equal to 2 to the x plus 6 by translating the graph, the parent function, 2 to the x, 6 units to the right. What mistake did Tariq do? Well, we notice that it's a plus 6. When it's a plus 6, this is going to be up and down. And it's going to be up 6, not to the right 6. So should have shifted up 6. Okay, so shifted up 6, not right or left. Number 4, as the value of k switches from a positive to a negative number, what is the effect on this graph? It's just that if I go from positive, it's going to go down. If k is positive, it goes up. K is negative, it goes down. Okay? So continuing on page 132, it says compare the graph 2 to the x plus 1 to the parent function of 2 to the x. So what does it do? It's going to shift up 1. Okay, so therefore the asymptote is going to shift up 1. And we know the asymptote is usually y equals 0. So now my asymptote is going to be y equals 1. What happens to the y-intercept? It also shifts up 1. So I'm going to take what my current 1 plus whatever k is. So I'm going to have 1. So my y-intercept is 0, 2. Because it's going to shift up 1, and my y-intercept in my parent function is always 0, 1. Now, on this one, we notice that it's up in the exponent on number 7. So therefore, we know it's going to be a horizontal shift. It's a minus, so we're going to go in the opposite direction. So instead of going negative, we're going to actually shift right. 1. Because it is a horizontal shift, your asymptote does not change. Okay, and your y-intercept, we're going to go the old-fashioned way. This is going to be 2 to the 0 minus 1, so 2 to the negative 1. So my y-intercept becomes 1 over 2. Good. So let's jump to number 9. Again, this is a horizontal shift because it's up in the exponent. We have a plus. We know it's in a horizontal. It's going to go the opposite direction. So this is going to shift left 1. Because it's a horizontal shift, my asymptote does not change. And my y-intercept, I can always just plug 0 in. So it's going to be 2 to the first power, which is just 2. Okay, so your y-intercept is 2. Number 10, compare the function represented by the graph of g of x equals 2 to the x minus 3 to the function represented by the table. So a lot of times what's easiest if we start off by looking at what is just 2 to the x. Well, if I have 2 to the 0 power, that's 1. 2 to the first power, that's 2. And it's easier to compare those than when we get up in these numbers right here. So for j of x, compared to the original, it is shifted up 1. So J is up 1 compared to, okay, because this shifts up 1, this shifts up 1 to 3. So shifts up 1 compared to 2 to the x. Now this one here shifts down 3. So if I compare these two, I'm up 1 here, I'm down 3 here, so I'm 4 up that, let's see, we go J of x is shifted 4 above G of x. The 11 and 12, we're going to just compare more and what's happening. These are all going to be horizontal shifts. This is going to shift to the left 1. My asymptote does not change. My y-intercept, I'm going to plug a 0 in. It doesn't matter what the parent function is. It's still going to do the same stuff. Okay, so here my parent function. So my graph, yes, it would change. But it's going to change by the same amount of things. So here, it's going to shift to the right. It's going to have an asymptote that doesn't change, and my x-intercept is going to plug 0 in here, so I'm going to plug 0 in. I'm going to take 0.4 to the negative 1, which would be 10 over 4, so that would be 5 halves, or 2 1/2. Okay? Again, we're going to do the same thing. What does this do? It shifts the entire graph up 1. It shifts the entire graph down 1. It doesn't matter what the parent function is. And if you're ever in doubt on the homework, just go out to Desmos and plug in the functions. Plug in the parent function first. So right here, that is your parent function, right? This is the parent function. So now I then plug in this one and I can compare. Now I made up one other one, and I'd like you to put this in place of, on page 134, put it on page number 5. So write this in number 5. How is the graph g of x equals 2 to the x minus 5 minus 3 compared to 2 to the x? So we're just going to look at the shifts. If I just look at the shifts here, okay, look at my shifts. So this right here tells me that it's going to shift down 3. And this is going to tell me that I'm going to go right 5. Okay, your asymptote is going to change based off of this. Your x-intercept is going to change based off of this. Okay, so here my asymptote changes, and then this is going to change my y-intercept. And what you do for that is just plug 0 in. Just plug 0 in and find it. Okay, so your homework is out there, and it will be due in 2 days, so go! And if you have any questions, you know where to find us.